Topic 4-2. I want us to practice some more on converting from scientific notation to standard form, and then from standard form back to scientific notation. So looking at this problem, it says convert to standard form 6.7 times 10 to the third. To convert to standard form, we will take 6.7 and multiply it times 10 to the third. Well, when you multiply it times 10 to the third and your exponent is positive, this exponent tells me to move my decimal 3 places to the right. Positive 3 exponent says move your decimal 3 places to the right. So here we go. 1, 2, 3. And fill in the open spaces with 0. Therefore, your standard form is 6,700. That is your answer to this problem. We're going from scientific notation to standard form. Let's look at our next example. Convert to standard form. We're in scientific notation. This is a product. This number is greater than or equal to 1, and it must be less than 10 times a power of 10 to an exponent. That is an integer. So you take your 7.42, take the first number, times 10 to the negative 3. If your exponent is negative, you are to move your decimal 3 places to the left. If your exponent is negative, you move your decimal to the left 3 times. So we'll move our decimal to the left. 1, 2, 3. Here's the decimal. Now you have to leave me a decimal if it's anywhere except behind the last digit to the right. So I must leave the decimal out front and fill in the open spaces with 0. Therefore, my answer is 0.00742. That's your answer. Now, looking at this answer, my decimal was behind the last digit to the right. Therefore, I can leave it. I don't have to put it. That's the only time you do not have to put a decimal. If your decimal is anywhere else, you have to put the decimal. So if I didn't have the decimal in this answer, it would be wrong. So 0.00742. Now let's convert the next number to scientific notation. So you have to have your decimal behind the first non-zero digit, which would be 6.74. And you're to write down every number all the way down to the last digit that is a non-zero number. So that's the reason why you have to keep 6.74. This number is less than 10. Times 10 to some power is how we leave our answer in scientific notation. Now think about it. If your decimal was here, as it is in my listing of scientific notation, how many decimal places would I have to move my decimal to the right to get the decimal back here? Because in the original problem, your decimal is at the back because I don't see a decimal. But if I put the decimal in between 6 and 7, think about how many places we've got to move it till we move it to the very back. So let's move it. 1, 2, 3, 4, 5, 6, 7, 8. I had to move it 8 places to the right. So to write the original problem, which did not contain a decimal, therefore it was understood to be at the back. This is your original problem. Think of your decimal behind the 6. I had to move it 1, 2, 3, 4, 5, 6, 7, 8 places to the right. Therefore, scientific notation, this is your answer. Scientific notation is 6.74 times 10 to the 8th. And the last one, convert to scientific notation. This one's 0.0000765. Now remember, your decimal has to be behind your first non-zero digit number, and then write down to your last non-zero digit number. Times 10 to some power to write your answer in scientific notation. Now, my original problem does have a decimal. Okay? So think about it. If your decimal's here at 7.65, how many places would I need to move it to the left to get it to the very front of the number? So if I move it 1, 2, 3, 4, 5, 6 places to the left. Well, to move your decimal to the left 6 places, your exponent has to be -6. So 7.65 times 10 to the -6 would tell me to move my decimal that's in between the 7 and the 6 places to the left. 1, 2, 3, 4, 5, 6. So scientific notation for this number would be 7.65 times 10 to the -6.